All right, guys, let's dive into the Unit 1 review. All right, so number 1, you're trying to take the square root of -9. You cannot take a square root of a negative number, so this is not a real number. At some point, we will learn how to do this, but we don't know how to do it yet. All right, so not a real number. All right, on number 2, we need to add these up, so you got square root of 25, which is 5. On 3, we need to solve these individually and then put them together. So you get the square root of 64, which is 8, and then the square root of 36 is 6. So you add those up, you get 14. All right. Now on 4, we're simplifying. So we need to break this apart. We need to say 243. All right, so that's going to be 81 and 3. So you're trying to find the biggest perfect square that goes into that, and it's going to be 81 and 3. And again, I like to separate these as to what can be pulled out and what can't. And so I got 81x squared times 3. And when I simplify that, it's going to be 9x square root of 3. All right, the 3 stays inside. Okay, so there's that. All right, let's see. 5, we need to multiply these first. So 6 times 42 is going to give us 252. 252x cubed. All right, now we simplify, and that's going to break down into 36 and 7. All right, it's not obvious, and again, you can go for the whole thing, or you can baby step it. So if you want to go for the whole thing, it's going to be 36 and 7, and then x squared and x. All right, so the square root of 36x squared is going to be 6x square root of 7x. All right, and then when you divide, you can combine these, and so that would be 120 x to the fourth over 5x, and so that's going to be the square root of, let's see, 24 x cubed, and then we need to simplify that. So that would be square root of 4x squared times 6x, and so that's going to give us 2x square root of 6x. Okay. All right. On 7, we're adding and subtracting radicals, and we can't do that unless we have common radicals. And so I need to simplify the second one. So I got -5 square root of 3, and then I got -7, and then I simplify this. This is going to be 25 times 3. All right, so that's going to be -5 square root of 3 minus. All right, the 5 is going to come out, and it's going to multiply to the 7, so it's going to be -35 square root of 3. And so now the radicals are the same. I work with the numbers on the outside. -5 minus 35. Remember, -5 is the same. Minus 35 is the same thing as -5 plus -35. So signs are the same. So I'm going to add and keep the sign. So it's going to be -40 square root of 3. Okay. All right. And then on 8, same thing. We got to simplify everything. So this is going to be 5 plus. We just did this, so this is going to be 81 and 3 plus, that's going to be 11 plus, let's see, that's going to be 9 and 12, or 36 and 3. So the square root of 3's is kind of the indicator that I want 3 times something to break this apart. So I want a perfect square times 3, so I can get the perfect square to come out, and then I can eventually add these together. So I got 5 plus, well, I can go ahead and combine these. That's going to be 16 plus 9 square root of 3 plus 6 square root of 3. And so that's going to be 16 plus 15 square root of 3. 16 plus 15 square root of 3. All right, rationalizing your denominator. All right, sometimes you need to multiply by itself, and sometimes you just need to multiply by the next thing to get it to the next perfect square. So here, I'm going to multiply by itself, square root of 19 over square root of 19, and that's going to give me 19 square root of 19 over 19. And so the numbers out front cancel, and I'm left with square root of 19 as my answer. All right, on 10, First of all, I know what square root of 49 is, and so this is going to be square root of 2 over square root of 2 because I got to rationalize. All right, so we know square root of 49 is 7, so that's 7 square root of 2 over 2, and that's my answer. I can't simplify that any further. All right, and then if you have multiple terms in the denominator, you still can rationalize it. You just have to multiply by the conjugate. So the original is 7 minus square root of 3, and so I'm going to multiply by 7 plus square root of 3, top and bottom. All right, so this gives me 3 times 7 plus square root of 3 over 49. Square the first term, square the second term, and subtract. So 49 minus 3. All right, so this is going to be 21 plus 3 square root of 3 over 46. All right, and you can't do anything with that, so that is my answer. All right, number 12. All right, once again, we're going to multiply by the conjugate. So I got square root of 2 minus square root of 5. Square root of 2 minus square root of 5. All right, so I got 3 times square root of 2 minus square root of 5 over, all right, that's going to be 2 minus 5. So that's going to be 3 square root of 2 minus 3 square root of 5 over negative 3. Well, the 3's can all cancel. All right, so that's going to be, and the negative is going to come up, so it's going to be negative square root of 2. Well, let's do it this way. That's going to be square root of 2 minus square root of 5 over negative 1. And I can bring that negative up and say negative square root of 2 plus square root of 5. Okay. So there you go. All right, simplifying radicals that have a higher root. All right, so the fifth root of 243, that's going to be 3. And your calculator can handle that. If you say 243, I think there's a button where you can do the fifth root, or you can even say 243 to the 1/5 power. Remember fractional exponents are roots, so you can do that as well. So that's just 3. Let's see, fourth root of 81 is also 3. All right, and then, all right, we're taking the cube root of x to the 8th. So this is going to be, again, fractional exponents. So the root is going to be my denominator, so it's going to be 8 over 3, x to the 8 thirds. And, all right, so what we're going to do is we're going to simplify this. And so that would be cube root of, how many 3's going to 8? 6. And so that's going to be x to the 6, x squared. And so I can pull the 6 out, and so that's going to be x squared, cube root, x squared. All right. 16. I'm going to multiply these together, and so this is going to be the cube root of 135. All right, so I need to simplify that. All right, so this is going to be 27 and 5. Okay, so the cube root of 27 is 3, and then I got the cube root of 5. Okay. 17. Again, I need to simplify these first. So I got 9 cube root. We just did the 135, so that's 27 and 5 plus cube root. It's going to be 8 and 5. Again, the 5 is the kind of the indicator of what you need to divide by. All right, so this is going to be 9. The cube root of 27 is 3. So 3 times 9 is 27. So you got 27 cube root of 5 plus the cube root of 8 is 2. So you got 2 cube root of 5. And now that you got the cube root of 5 on both of them, you can add 27 and 2, and you get 29 cube root of 5. All right? All right, so again, fractional exponents. This is saying the square root of 16, which is 4. 16 to the 1/4, that's saying the fourth root of 16, which is 2. All right, on 20, you got the cube root of 64, and you're going to raise it to the fourth power. So the cube root of 64 is 4 to the fourth, which I believe is 256. Yeah. All right. And then, all right, now we got a negative exponent. So this is going to be 1 over the square root of 36 to the third power. So 3 halves is the square root of 36 raised to the third power, but because of the negative, it drops to the bottom. And so the square root of 36, that's going to be 1 over 6 cubed. So it's going to be 1 over 216. All right, I'm going to multiply these together. So you have 5 times 3 is 15. X to the 3/4. When you multiply like bases, you add exponents, so 3/4 plus 1/2. You can use your calculator to help you with that. So it's going to be 15 to the 5/4, or 15x to the 5/4, like so. All right, when you divide like bases, you subtract exponents. So this is going to be 2x to the 2/3 minus 1/4. And again, use your calculator to help you with the fractions. And you get 2x to the 5 over 12. All right, and then you're taking the 1/2 says I'm taking the square root of all that. So this is the square root of 36, x to the 6, y to the 4th. And the square root of 36 is 6. And then for the exponents, as long as they can be divided by 2, then they can all come out. And they can. They're all even. So this is going to be x cubed y squared. 6x cubed y squared. Okay. All right, so that's page 1. All right, let's look at page 2. All right, so on 25, we are reducing the index. So we have x to the 9 over 12, which reduces to 3 over 4. So I can rewrite this as the 4th root of x cubed. All right, factoring out a GCF. So we're getting into factoring now, and we will continue on with factoring for the next little section. So what do all three of these have in common? Well, they all have a 3 in common, so I can pull out a 3. They also all have an x squared in common, so I got x squared, and that's going to leave me with 7x squared minus 3x plus 4. Okay, so there's that. And then on 27, they both have an x plus 3 in common, so I'll pull that out and put the pieces together. So I got x plus 3 times x plus 5. Okay, so there's no rule that says a binomial can't be a GCF. All right, now, when it comes to factoring, if you got 4 terms, you're going to factor by grouping. So I group the first 2 terms and the second 2 terms. All right, so the first 2 terms have an x in common, so I got x squared plus 9. And then I'm going to take a 5 out of the other 2, so it's going to be plus 5. And that's going to also leave me with x squared plus 9. And then now it looks just like 27. You got x squared plus 9 coming out front, and then put the pieces together, you get x plus 5. Okay. Once again, we're going to factor by grouping. All right, so you got 3x squared coming out, leaving me with x plus 2. I'm going to pull out a 7. It's also going to leave me with x plus 2. And so I'll pull the x plus 2 out front and put the pieces together. You get 3x squared plus 7 in the back. Now, because it'll come up, it doesn't matter which order these parentheses are in. So just be mindful of that. All right, so for 30, we're just factoring. So 2 parentheses, x squared breaks down to x and x. My second sign is positive, so both signs are the same as the first. So I got plus, plus. And then I ask myself, what times what is 54 and adds to 15? Oh, that's going to be 6 and 9. Could it be 9 and 6? Absolutely. All right, on 31, we factor this. X, my second sign is negative, so I got plus and minus, 1 of each. All right, what times what is 45 and subtracts to give you 4? Well, that would be 9 and 4. 9 is bigger, or sorry, 9 and 5. 9 is bigger than 5, so 9 gets the middle sign, so that's minus 9 plus 5. If your signs are the same, order doesn't matter. It doesn't matter where you put your numbers. But if signs are different, it absolutely matters. So you need to pay attention to that. All right, on 32, you got x plus, minus. What times what is 40? And subtracts to give you 6. All right, well, that's going to be 10 and 4. And so because 6 is positive, it's going to be plus 10 minus 4. 33. There's not a GCF I can take out, so I'm going to take the 7, throw it to the back, and multiply when I get there. So I got x squared plus 30x plus 56. Okay, that's the AC method. So now I factor. I got x and x plus plus. What times what is 56 and adds to 30? Well, that would be 2 and 28. 2 and 28. And because I started this thing by multiplying by 7, I now have to divide by 7. All right, I take a step and reduce any fractions that I can. So I got 2 over 7 doesn't reduce. 28 over 7 is 4. Any denominators that are left, you're going to throw up in front of the x. So this final answer is going to be 7x plus 2, x plus 4. Okay. Once again, I'm going to do the AC method. So I got 7, throw it to the back. You got x squared minus 31x plus 84. Let's see, x minus. My factors of 84 that are going to multiply to 84 and add to give me 31 is going to be 3 and 28. Again, I started by multiplying by 7, so I got to divide by 7. And so this will look very similar to the one before it. X minus 3 over 7, x minus 4. And any denominators that are remaining, get thrown up in front of the variable. So I got 7x minus 3, x minus 4 as my answer. All right, starting with 35, we have our special products. So this is a difference of 2 squares. So that's going to be x plus, x minus, and then you're going to square root of 36 is 6. So I got x plus 6, x minus 6. All right, because this only has 2 terms, you really need to know that formula. So make sure you know it. 36. All right, same thing. It's a difference of 2 squares, but you have x's and y's. Don't let that throw you. All right, so let's see. The square root of 64 is 8, so I got 8 and 8, x and x. The square root of 25 is 5, so I got 5 and 5, y and y, plus, minus. That's all there is. All right, if it's an even power, even if it's greater than 2, as long as it's even, it's a perfect square. All right, so this is going to be x squared plus x squared minus, and I believe that is 16. Yeah, so you got x plus 16, x minus 16, or x squared plus 16, x squared minus 16, and then the x squared plus 16 isn't special. So you got x squared plus 16, bring it down. X squared minus 16 is the difference of 2 squares yet again. So you just keep going until you can't go any further. So that's going to be x plus 4, x minus 4. All right. Let's see. On 38, the first term and the last term are perfect squares. So if you don't recognize that, you can use the AC method, which in this case, it wouldn't be too bad, but I don't recommend that. I recommend the formula. So let's see, that's going to be 6x and 6x, 1 and 1, minus and minus. Now, before you're done, you want to check and make sure you get the middle term out of it. So what you're going to do is you're going to multiply the insides together, the outsides together. You get negative 6 and negative 6. That is 12, negative 12. So that checks. And so I can finish this by consolidating 6x minus 1 all squared. All right, so set up your parentheses, check to see if it gives you your middle term, and then you're good. All right, now 39 and 40 is the sum and difference of 2 cubes. Remember, that's going to give you, if you got a cubed plus b cubed, you got a plus b, a squared minus ab plus b squared. And if it's a cubed minus b cubed, you got a minus b, a squared plus ab plus b squared. All right, so keep those in mind. And then this is going to be 4x minus 1. And then you build your trinomial off of your binomial. Square your first term, so you get 16x squared. Multiply your terms together and change the sign, so it's going to be plus 4x. And then square your last term, so plus 1. And that's it. On 40, you got 4x plus 5. You take the cube root of both of those, and that's how you get that. And then building your trinomial, square your first term, you get 16x squared. Multiply your terms together, change the sign, so it's going to be minus 20x. And then square your last term, you get plus 25. All right. Now, on 41, again, you always check to see if you have a GCF. That's where you start. So here, 5 goes in all of these, so I can pull that out, and that leaves me with x squared plus 13x plus 40. All right, and so at this point, you can keep factoring to see if the trinomial factor, and you get x plus plus. All right, 5 and 8 give you multiply to 40 and add to 13, so you get 5 and 8. And so that's your answer. On 42, you have two terms, so this could either be a sum or difference of two cubes or a difference of two squares. Right now it's nothing because 5 and 80 are not perfect squares, but 5 goes into 80, so I can pull that out, and that's going to give me x to the fourth minus 16. And so that's going to be 5 times x squared plus 4, x squared minus 4. The plus 4 doesn't mean anything. It's not special, so you just bring it down. But the x squared minus 4 is yet another difference of two squares, so you say x plus 2, x minus 2. All right, so there's that. Now, rational expressions. So when you're multiplying, you just want to make sure everything's in factored form. So let's see, we got 3. That's going to be x minus 1 on top, x on the bottom, 4x squared, 7. Factor it out, you get x minus 1 on the bottom. All right, so I can get rid of the x minus 1s. I can get rid of one of the x's. And so 3 times 4x is going to be 12x over 7. 12x over 7 is my answer. All right, 44, we step up in complexity. We need to factor every one of these things. So let's do that. All right, so we got parentheses galore. All right, x squared plus 11x plus 18. So we got x and x plus 2 and 9. Multiply to 18 and add to 11. All right, on the bottom, you got x plus 2 and 8. Multiply to 16 and add to 10. On the top right, you got x plus 7 and 8. Multiply to 56 and add to 15, so 7 and 8. X plus, that's going to be 7 and 9. Multiply to 63 and add to 16. All right, so I got everything factored. So let's see what I can get rid of. I can get rid of the x plus 2s. I can get rid of the x plus 7s, the x plus 8s, and the x plus 9s. So everything falls out, and I'm simply left with 1. Okay? So if you get rid of everything like I just did, the answer is not 0. The answer is 1. Because remember, when you cancel, you're essentially dividing. So when you divide something by itself, you get 1. So you got 1 everywhere. Now, we're dividing on 45, so we have to flip the second fraction and change it to multiplication. So the second fraction looks like this, 40 over 10 times x minus 8. All right, now on the first one, we factor like normal. We don't flip anything. So 4x minus 8. And then the x squared minus 16x plus 64, that gives me x minus 8 and 8. So let's see what I can get rid of. I can get rid of the x minus 8 here. This x minus 8. This 4 goes into 40 10 times. And then 10 over 10. So once again, I'm left with 1. Now, you could have crossed out all your parentheses and said 40 over 40 and still got 1. Like, so whatever you want to do, however many steps you want to add that makes you feel comfortable, do that. All right, last page. All right, so 46, we are dividing again, so I need to factor everything. And I need to flip that second fraction and change it to multiplication. So x squared plus 2x is going to be x plus 2. And then that's going to be x plus minus. All right, 4 and 8 give you 32 when you multiply, and subtract to give you 4. So, and 8 is bigger, so it's plus 8 minus 4. All right, so let's go back over here and factor this. So we got x and x plus 2 and 7 multiply to 14 and subtract to give, or add to give you 9. You got x plus. It's going to be 7 and 8. We just did that one on the previous problem. All right, so let's see what we can get rid of. We can get rid of the x plus 2's. We can get rid of the 7's, the plus 8's. And I'm left with x minus 4 over x. All right, 47. All right, this time I'm adding. Here, my denominators are common. So I can go straight to work saying 10x minus 1 plus 3 minus 9x over x squared plus 7x plus 10. All right, so let's clean that up. That's going to be 10x minus 9x is x, and then 3 minus 1 is 2, so I get x plus 2. All right, let's go ahead and factor this bottom, see if I can get rid of something here. So it's going to be x plus 2 and 5. All right, so that allows me to get rid of the x plus 2's, and my answer is 1 over x plus 5. All right, so you want to get it down to a single fraction and then try to simplify. Okay, so on 48, you have x minus 12 and 12 minus x. Because they're minus and not pluses, these are not the same. However, if I take a negative out, I can rewrite this as positive x and minus 12. And then x minus 12 is the same. And I can actually bring this negative up and make this positive, like so. And then it's simply 2 plus 4 over x minus 12. And that's going to give me 6 over x minus 12. All right, 49. All right, these are not the same denominator, so I need to factor them. All right, so let's see. I got x plus 5 and 7. Here I got x and x plus minus 2 and 7. 7 is positive. All right, so they both have a plus 7. So I need to multiply by what they don't have. All right, the right side does not have an x plus 5, so I need to multiply by that. The left side does not have an x minus 2, so I need to multiply by that over here. All right, so that's going to be x minus 2, x plus 8, plus 3x plus 1, x plus 5, all over my new denominator of is a combination of all three, and I would leave it factored. X minus 2, x plus 5, x plus 7. So from here on out, we're just got to clean up the top. All right, so that's going to be x squared plus 6x minus 16 plus 3x squared. Let's see, it's going to be 15x. It's going to be 16x, and then plus 5. All over that denominator, x minus 2, x plus 5, x plus 7. All right, let's clean it up. All right, so let's see, we got x squared and 3x squared is going to be 4x squared. All right, so if it helps, mark your like terms. Okay, so 1 and 3 is 4x squared. 6 and 16 is going to be 22x. And then negative 16 and 5 is going to be negative 11. 4x squared plus 22x minus 11 over that denominator, x minus 2, 4, or x plus 5, x plus 7. All right, you can try to factor the top using the AC method. Nothing's going to work out, so this is my answer. okay? And then here, 50, our last one, we have x plus 1, x minus 1. I need to factor the last one, so you got x plus 1, x minus 1. So, all right, so the first one has an x plus 1, so I'm going to multiply 5x times x minus 1 plus 6. It has an x minus 1, so I'm going to multiply by x plus 1 minus, this one has both, so it's just going to be minus 10. All right, so all of this is over x plus 1, x minus 1. All right, so let's see, we got 5x squared minus 5x plus 6x plus 6 minus 10. Right, all over x plus 1, x minus 1. All right, so that's going to be 5x squared. That's going to be minus x and minus 4. X plus 1, x minus 1. This one will factor, so let's do that. Let's do 5x squared minus x minus 4, AC method. So let's see, we got x squared minus x minus 20. That's going to factor x plus minus. All right, so you have 4 and 5, and 5 is going to be bigger, so it gets the sign of the middle term, so plus 4 and minus 5. I started by multiplying by 5, so I got to divide by 5. All right, so let's see, I got x plus 4/5, x minus 1. All right, so you see the x minus 1 shows up, and that's what I'm going to use to factor this thing. So that's going to be 5x plus 4, x minus 1. I take that and put it in my numerator to get 5x plus 4, x minus 1, over x plus 1, x minus 1. All right, the x minus 1 just get to leave, and I'm left with what's left, 5x plus 4 over x plus 1. All right, so that's your review for Unit 1. Watch this as many times as you need to, and I'll see you in class.